It's hard to believe, but the ground beneath Utah is cracking open. Residents are reporting rumbles and sinkholes, and satellites show the rupture spreading fast across the state.
If you live in the St. George metro area, Pine Valley provides cool comfort when summer heat arrives. In Utah, temperature is more related to elevation than to the north-south latitude.
It seems unreal, but beneath Utah's deserts and mountains, something extraordinary is unfolding. A region once labeled among America's most steady landscapes is literally beginning to split. Over recent months, people across central and southern Utah have reported rattling, gaps opening, and sinkholes where solid ground once stood. Satellite observations back those accounts. The land under Utah is fracturing, and the break appears to be widening rapidly. Initially, scientists suspected groundwater extraction or slow fault creep. Yet, when seismic stations near the Wasatch Front recorded harmonic tremors, deep, low-frequency pulses often linked to volcanic or tectonic unrest, researchers recognized an unprecedented event in progress. A fissure roughly 40 miles long has opened along a corridor from Fillmore to Richfield, cutting through farms, canyons, and stretches of highway like a raw wound. In some places, the surface has dropped more than 2 feet within days, while neighboring ridgelines have risen as if being pushed upward. Drone footage released by the USGS displays vast cracks sweeping the desert and crossing ancient volcanic fields and quiet faults that have slumbered for millions of years. Worryingly, the fracture is not fixed. It is propagating. Fresh satellite mapping shows deformation zones pushing southwest toward Cedar City and eastward toward Capitol Reef, implying the crust is being pulled apart by deep-seated forces. Thermal scans detect subtle heat anomalies emerging near the breaks, dim glows invisible at ground level. A number of experts now raise the possibility that magma is ascending through the lower crust beneath Utah's basin and range, linked to a vast subterranean system running from Nevada toward Yellowstone. Although Utah's landscape has been formed by stretching crust for millennia, the present pattern is unprecedented in scale. The evidence points to the region entering an active rifting phase, one that could permanently reshape parts of the American West. If the ground beneath Utah is indeed ripping open, what might rise from below? What unknown forces, fluids, or molten rock could emerge to reshape landscapes, ecosystems, and communities above? Chapter 1. The crack that shouldn't exist. It began as a thin line in the sand, a crack barely wide enough to slip a finger into. Ranchers outside Fillmore, Utah noticed it first. Overnight, fences had twisted out of alignment, irrigation pipes had snapped, and a faint sulfur smell lingered in the cool desert air. When they returned the next morning, the crack had grown into a canyon. What started as a 3-inch fracture had widened into a gaping chasm more than 20 feet across and several miles long, cutting straight through farmland, gravel roads, and the open plains. Locals thought it was an earthquake, but there had been no quake. The ground had simply torn itself apart. By the time USGS teams arrived, the fissure had already expanded in both directions. Using drones and LiDAR mapping, they discovered that the crack stretched over 40 miles, aligning perfectly with an ancient fault buried deep beneath volcanic rock. It wasn't a coincidence. It was a reactivation. Core samples from the edges of the fissure revealed something no one expected. Freshly fractured basalt, still warm to the touch, glowing faintly under thermal cameras. That shouldn't have been possible. The rock beneath Utah's surface should have been cold and brittle, not alive with heat. Satellite INSAR readings soon confirmed what on-site measurements hinted at. The ground wasn't just breaking, it was lifting and separating at the same time. Pressure was building from beneath, pushing upward as if something massive was forcing its way through the crust. When scientists compared the fissure's growth rate to other rift zones around the world, the results were staggering. Utah's crack was spreading at nearly 5 times the normal rate of continental extension, rivaling zones in East Africa and Iceland, both known for active magma intrusion. And then came the sound. Late at night, residents reported hearing a deep, hollow roar beneath the desert floor, a vibration that resonated through the soil like distant thunder. It wasn't wind, and it wasn't seismic noise. Instruments placed near the fissure picked up a subsonic hum repeating every 47 minutes, the same rhythmic pattern that's been recorded before volcanic eruptions. Experts now fear the fissure may not be a simple crack at all, but the birth of a new rift, a zone where the continent itself is beginning to pull apart. If Utah's crust has started to split open, the question isn't just why, it's what's trying to rise through it. Chapter 2. The hidden heat beneath the desert. The first signs of what lay below came from the air. When NASA's Terra satellite passed over Utah's basin and range region, it detected faint thermal hotspots scattered across a 70-mile stretch of desert, right above the newly formed fissure. The readings were subtle, only a few degrees above normal, but they were spreading outward week by week. At ground level, USGS geologists used portable infrared scanners to confirm the data. What they found was chilling. Patches of desert soil warm to the touch even before sunrise, as though heat were rising from below. One team near Severe Dry Lake reported thin wisps of steam seeping through the cracks, vapor that carried the unmistakable smell of sulfur and iron. When they lowered temperature probes into the fissure, the results shocked even veteran researchers. The air down there was nearly 160 degrees Fahrenheit, rising steadily the deeper they measured. Something hot, very hot, was forcing its way toward the surface. Core samples and magnetotelluric surveys revealed a massive conductive body sitting about 15 kilometers beneath central Utah, a magma reservoir roughly the size of Salt Lake City. It had likely existed for millions of years, dormant and trapped within thick layers of crust. But now, it was on the move. Scientists believe that shifts in regional tectonic stress may have fractured the caprock, allowing molten material to rise into the fissure system. Gas sensors confirmed increasing emissions of carbon dioxide, sulfur dioxide, and helium-3, all classic signs of magma degassing. Suddenly, Utah's deserts weren't quiet plains anymore. They were the roof of a growing underground inferno. If magma is indeed rising beneath Utah, the state may be witnessing the birth of a new volcanic province, a geologic event that hasn't occurred in North America in nearly 10 million years. And if that's true, this isn't erosion, it's creation. If this story left you questioning the ground beneath your feet, don't stop here. Subscribe, stay alert, and join us as we uncover what happens next when America's heartland begins to break apart. Because this isn't fiction. It's the slow beginning of something real, and the Earth's next great transformation has already begun. Chapter 3. The faults that woke up. The crack didn't stay alone for long. In the weeks that followed, earthquakes began rippling across Utah, small sharp jolts that rattled windows but didn't cause major damage. But when seismologists mapped their epicenters, they noticed something terrifying. They weren't random. They were forming a perfect line. From Delta to Cedar City, from Capitol Reef to the Escalante Plateau, dozens of previously silent faults had begun to move. They were reactivating, all at once. GPS and INSAR satellites showed entire blocks of crust sliding apart like puzzle pieces under stress. The Wasatch Fault, capable of producing magnitude 7+ quakes, began showing measurable slip for the first time in over a century. Even more disturbing, Tremors were recorded along faults that cut directly beneath Salt Lake City and Provo. But it wasn't just seismic movement, it was deformation. The crust across Utah was stretching east to west, pulled apart by forces deep below. The state wasn't just cracking, it was expanding. Seismic tomography confirmed the link. The earthquakes were aligned along the edges of the magma reservoir discovered beneath Sevier Valley. The molten intrusion was literally tearing the state open from the inside. Experts compared the readings to rift zones in East Africa and Iceland, regions where continents are actively splitting. The resemblance was almost identical. If the faulting continues, the western half of Utah could slowly begin to detach from the continental plate, a process that might one day create a new ocean basin where farmland and mountains now stand. For now, the rift is still shallow, but the stress is building. And as cracks spread toward the Rockies, one haunting truth is becoming clear. Utah isn't just part of the continent anymore, it's becoming the edge of it. Chapter 4. The lakes that began to boil. Then came the water. Utah's inland lakes have always been the heart of its ecosystem. Utah Lake, Sevier Lake, and the iconic Great Salt Lake. But in early summer, sensors monitoring water temperature began returning impossible data. Surface readings were spiking, and not from sunlight. Over a single weekend, parts of the Great Salt Lake warmed by nearly 8 degrees Celsius. Steam began rising across the brine flats, even at night. Birds avoided nesting sites they'd used for decades, and boat captains reported patches of water that bubbled like a simmering pot. Thermal drones soon revealed what was happening. Superheated groundwater, likely connected to the underground fissure network, was venting directly into the lakes. Beneath the surface, fresh cracks were channeling geothermally heated fluids upward. By mid-July, fish kills were reported in Utah Lake as oxygen levels plummeted. In the Great Salt Lake, white-crusted salt formations began to glow faintly red under infrared, a sign of thermal energy radiating through mineral deposits. Scientists installed pressure sensors and made a grim discovery. In certain areas, the lake bed was rising, swelling from below. One researcher described it as the water breathing. The USGS warned that if the uplift continues, sections of the Great Salt Lake could breach into surrounding land or collapse inward, triggering massive mud geysers and sudden drainages. For a region already facing drought, the idea that its few remaining lakes might boil or vanish underground sent shockwaves through local communities. Utah's deserts were heating, its lakes were boiling, and its crust was splitting open. If the land beneath this state is truly awakening, then the Great Salt Lake may be more than a remnant of ancient seas. It could be the surface expression of something stirring below. Chapter 5. The mountains begin to move. By late August, the Wasatch Range, long thought to be Utah's immovable spine, began to tremble. Ground deformation data showed the mountains tilting eastward, subtle but measurable. Rock slides echoed through the canyons outside Ogden and Provo. Locals reported cracks splitting mountain roads overnight, like veins branching from a deeper wound. Then, on September 3rd, GPS instruments at Mount Nebo recorded an upward movement of nearly 6 centimeters in just 48 hours. The mountain was rising. It wasn't a local uplift. The entire Wasatch Range was bulging. Scientists believe the same magma body that caused the desert fissure had spread beneath the highlands, pushing upward on the mountain roots. Deep seismic reflections showed molten intrusions climbing into the crust. Not yet near eruption, but close enough to deform the landscape above. Meanwhile, microquakes spread into Colorado and northern Arizona, tracing the same pattern as the Utah Rift. The pulse of Earth beneath the Great Basin was expanding outward. Experts are calling this event the Utah Rift sequence, the first step in what might be a larger continental breakup. The land that once stood at the heart of the American West is now behaving like a tectonic frontier, alive, mobile, and volatile. The Wasatch Mountains, long symbols of stability, have become the trembling edge of a world being reshaped from below. And the question scientists more each day: if the mountains themselves are beginning to move, how much longer before the surface gives way completely? Chapter 6. The Rift Awakens. By fall, Utah's story was no longer a local phenomenon. It had become a global concern. Seismic stations across the world detected a deep, rhythmic vibration emanating from beneath the Great Basin. It wasn't an earthquake. It was something slower, heavier, more deliberate. The signal repeated every 42 minutes, pulsing like the heartbeat of the Earth. NASA satellites captured the most dramatic image yet, a faint but unmistakable glow of infrared energy spreading beneath central Utah. The pattern matched magma upwelling, a clear sign that molten rock had reached the shallow crust. Within days, the fissure near Fillmore began emitting gas, carbon dioxide mixed with traces of sulfur and water vapor. The smell of metal filled the air. Instruments recorded rising ground temperatures, and local residents reported hearing distant booms, as if the planet itself were exhaling. Scientists now believe Utah may be the center of a new continental rift system, one that could stretch across the American interior for centuries to come, splitting the land, birthing volcanoes, and rewriting the geography of the West. Chapter 7. The Fire Beneath the Fault. It wasn't the sound that terrified scientists. It was the silence that followed. As Utah's fissures widened, seismic stations began picking up a deep void in the data, a zone where tremors vanished completely. In geophysics, that silence means one thing: magma has broken through solid rock and is pooling in open space. Thermal satellites confirmed it. A vast magma reservoir, roughly the size of Los Angeles, had formed just 10 kilometers beneath the severe desert. It was unlike anything the USGS had ever seen in this region. Not a spherical chamber, but a network of glowing rivers of molten rock flowing through fractures like capillaries under skin. The magma was moving north, branching toward the Wasatch Range and Salt Lake Valley. Gas emissions skyrocketed. Hydrogen sulfide, carbon dioxide, and trace radon levels reached record highs, all the warning signs of a deep volcanic awakening. And yet, Utah's surface remained deceptively calm. No towering plumes, no lava, just the quiet swelling of a land under tension. But that stillness only made experts more uneasy. The pressure building below was now measurable through GPS uplift, reaching nearly 10 centimeters in just 3 weeks, the kind of displacement that usually precedes an eruption. Scientists began to wonder whether the fissure had created a new volcanic pathway, one not yet ready to erupt, but ready to tear apart the crust. The Earth's skin was stretching to the point of no return. In nearby Fillmore, ranchers reported seeing strange lights flickering across the desert at night. Not lightning, but ionized plasma rising from the cracks, glowing faintly blue in the dry air. Chapter 8. The day the sky turned red. On a cold October morning, Utah woke up under a blood-red sky. At first, meteorologists thought it was wildfire smoke, but satellite data revealed something far stranger. The coloration wasn't in the troposphere, it was in the ionosphere, where charged particles interact with Earth's magnetic field. Something beneath Utah was generating enough energy to disturb the upper atmosphere. At the same time, electromagnetic sensors across the state began to register magnetic pulses in repeating cycles, bursts of current powerful enough to interfere with aircraft navigation and ground communications. Pilots over the Great Basin reported compass failures and glowing streaks over the mountains, like auroras misplaced thousands of miles from the poles. Then came the tremor. It wasn't a sharp quake, it was a deep, rolling motion, like the land inhaling. For nearly 4 minutes, the entire central basin rose and fell by several centimeters. Lakes sloshed out of their beds, The air filled with static, and the red hue deepened until even the shadows glowed. Seismic readings later revealed that this pulse had come from beneath the fissure, not along it. Something massive had moved. A slab of crust nearly 60 miles wide had shifted upward in one single motion. Scientists now believed Utah was sitting atop a mantle plume, a rising column of molten material slowly forcing the surface upward. It wasn't just Utah cracking open. It was the beginning of a new hotspot, a process that could last millions of years. The red sky faded by nightfall, but the signal it left behind didn't. Every sensor in the western US recorded it, a single, low-frequency wave radiating outward from the severe desert, echoing through the crust like a heartbeat. The planet had spoken, and it was far from done. If the red sky was Earth's warning flare, then the question haunting every scientist became clear. Was this the birth of a volcano, or the first sign of a continental rupture?
Chapter 9. The Awakening of Stone.
It happened just before dawn. Across Utah, every seismic station registered it simultaneously, a massive harmonic tremor that shook the crust without breaking it. The earth didn't crack this time. It shuddered, like something alive, straining against the weight of its own creation. Then, silence. The fissures that had stretched for months began to glow faintly orange, visible even from space. What drones captured next defied logic. Columns of heat rising from the cracks, not from lava, but from superheated gases, venting directly from the mantle. The Utah Rift was no longer a passive fracture. It had become a living geological artery, a new pathway between the Earth's core and its surface. Scientists across the globe declared it the beginning of a continental transformation. Utah, they warned, was now a proto-rift, the earliest stage of a future ocean basin, where continents are slowly torn apart by heat and time. The Earth had rewritten its own circuitry. Satellite radar revealed that Utah's crust was now permanently deformed, pulled apart by over a meter in some regions. The first scars of a new continent had formed. As calm returned, the question on every researcher's lips echoed like prophecy. If this was the first crack, where will the next one open? Because this wasn't an end, it was a beginning. The Earth had awakened beneath the American West, and its heartbeat had just started to quicken. If this story shook your view of the ground beneath us, don't stop here. Subscribe, turn on notifications, and stay with us as we uncover the next great shift in Earth's living crust. From magma corridors to collapsing lakes, every fault line tells a story, and the next chapter may already be forming beneath your feet, because this planet isn't done changing, and neither are we.